Hello everyone and welcome to my video on graphing systems of inequalities. You have already seen a video and learned how to graph inequalities, so it's going to focus more on the difference between just graphing one and graphing a system. So what I like to do when I do these problems is the first thing I do is I get the equations ready to be graphed. In this case, the x is less than or equal to -3. There's really nothing for me to do to get that ready. So that one's good to go. However, the other equation, it's in standard form. And while it is graphable here, I find the easiest thing for me to do is to just turn it into slope-intercept form. So let's go ahead and do that as our first step here. So I'm going to rewrite this. 5x plus 3y is greater than or equal to -9. I want to get y by itself. So the first thing I'm going to do is to subtract 5x on both sides. So we can get just the y term by itself, and that leaves me with a positive 3y. So I have 3y is greater than or equal to, and -5x minus 9. And then I'm going to need to divide everything by 3. So I'm going to go ahead and divide 3 on all terms in this inequality. Right, and then that's going to give me just 1y instead of 3y. So I get y is greater than or equal to -5/3 x minus 3. All right, so you just got to be careful here. Since it's in slope-intercept form, when I divide that -5x by 3 here, I'm going to want to write that as a fraction out front on the x after that so I can clearly see my slope. -9 divided by 3 is -3, so I got to make sure I get that. And of course, this turned to just a 1y. So we're good to go. All right, this is going to be where I'm looking now when I graph that line. So if I wanted to, I could just even like maybe move it over here so it's kind of with everything that we got going on. All right, so when you're graphing a system of inequalities, the first thing you want to do is just graph all the inequalities. And when you graph them, you're going to graph them as if they were the only thing on the graph. So in this case, for the first one, it is. So I'm going to graph x is less than or equal to -3. Now, when you have just one variable, it's going to be either a horizontal or vertical line. So if it's just x, in this case, we're going to have a vertical line. If it's just y, you're going to have a horizontal line. And since it's or equal to, we're going to do it as a solid line instead of a dashed line. Now, when I'm graphing with just x or just y, I know it's going to be horizontal or vertical. Sometimes I don't remember which one's which. So sometimes it's easier to just think about it like this. X is less than or equal to -3. I basically want to see and find out, hey, when is x -3? So I'm going to go over here, and most of us will probably think of x as being -3 right here, which it is, but I mean, it's not just -3 there, it's also -3 here, and here, and here, and here, here, and so forth. Right? It's not -3 here, it's not -3 here, so it's not going to be a horizontal line, it's going to be a vertical because that's the only direction I can move where that x is not going to change. Right? And it gets confusing because since the x values kind of move in a horizontal way, everyone thinks that an x line is the horizontal one, but that's not the case, right? Because you don't want your x value to change, so it has to go kind of against that, and it's going to go vertical here. So let's go ahead and do that line. Again, it's or equal to, so it's going to be a solid line. I want to extend it throughout the entire graph. And now I need to shade it. Right? So when you're doing inequalities, remember you have the line, but then you also need to shade. So in this case, x is less than -3. Now normally I would test a point, and you can in this case just grab any point that's not on that line and throw in just the x value. You don't need to worry about the y value because there is no y. But in this case, usually with a horizontal or vertical, I'll know where x is less than -3. And x gets smaller as you move left. So all the less than -3 is going to be this side of that line. Now again, you could have just grabbed any point over here, looked at its x value, plugged it into the inequality. So like a point on this side would have been, -7. When x is -7, it's less than -3. So since that's true, this is the side where all the solutions are. But I think with horizontal and vertical lines, it's going a little further than we need to. Most people should be comfortable with, what side is less than -3, what side is greater than. All right, so then the next one is the other equation. So y is greater than or equal to -5/3 x minus 3. So when I'm graphing this, the first thing I want to do is look at that y-intercept, which is -3 in this case. So I'm going to go to the y-axis, find my -3, and put my first point. Okay, then I'm going to look at the slope. In this case, the slope is -5/3. So that means I'm going to go down 5/3. So I'm going to count 1, 2, 3, 4, 5, 1, 2, 3, put my point. It looks like I can't go any further, but I can go in the opposite direction. So in this case, I went down and to the right. So now I want to go up and to the left. So 1, 2, 3, 4, 5, 1, 2, 3, put a point. 1, 2, 3, 4, 5, 1, 2, 3, put a point. It looks like I can't go any further. Again, this one is or equal to, so I'm going to have to use a solid line instead of a dashed. So I'm going to go ahead and do that. All right, so I'll get a nice line. It's a little off, but that's okay. I'm not going to change it. All right. Now, I need to find out what side to shade. And again, when I'm doing this second inequality, I'm just pretending the blue one's not there. Right? I don't even see the blue one in my head. I ignore it. I'm just graphing this inequality like it was the only one on the graph. Once I'm done doing them all individually, then we'll worry about, what does it mean to be a system. All right, so I need to find a point. Typically, I always use 0, 0 as my testing point, but you can only do that as long as that's not on the line, and you can see it's not, so we're good to go. So I'm going to throw in 0, 0 here. So I get 0 is greater than or equal to -5 times, or -5/3 times 0 minus 3. This turns to 0, so I basically get 0 is greater than or equal to -3, which is true. Since it's true, wherever that testing point was, that's a solution, and everything on that side has to be a solution. So since 0, 0 was over on this side, I know that's a solution. I know that whole side is a solution. So I'm going to go ahead and shade this whole side of the line. And again, you are ignoring the fact that there's even a blue line anywhere on this graph. Right, this is completely separate from the first one, just doing its own thing, not really worried about the other one. It's like, oh, I didn't even know you were there. Who are you? Right? And then once you're done, no matter how many inequalities there are, your answer is wherever the overlap is. Okay, wherever that overlap is, that's where your answer is. Now, in this case, the overlap is kind of this little wedge here. Since both lines are solid, the point at where they intersect is part of our solution. Right? Now, if one of those lines was dashed, it would not be part of our solution because that would not include that on that line, so therefore it's not an overlap of the two. It would still kind of be the border of the solution, but not an actual solution. So the only time in the intersection of all the inequalities is a solution is when all the inequalities are solid lines, so they have that or equal to. That also goes for the blue and red line that kind of make the border. Right? This blue line is also part of our solution because it is a solid one. And this red line is also part of our solution because it's a solid one. Right? So when it comes to the lines, if they're solid, they're part of their solution. And when it comes to the intersection, if all the lines are solid, it's part of our solution. And then when it comes to the shading, anything that falls in that border is part of the solution. So our solution area is here. So anywhere in this area is going to be a solution to this system of the inequalities. It will make all the inequalities in the system true. And of course, this little piece would just keep going on forever if our graph was any bigger. And that's all there is to it.